Okay, so this problem right here fits the category of a level surface problem with a horizontal applied force. So we have an object with a mass of 41 kilograms is placed on a surface. The coefficient of sliding friction between the two surfaces is 0.54. What's the force required to move the mass at 5.8 meters per second squared? Now, they don't say it's a level surface, but we will assume level unless they give me an angle, because if it wasn't a level surface, they would have to give me the angle of the incline. So I'm going to have a level surface, and I'm going to have an object on it. And as far as facts in the problem, it says an object with a mass of 41 kilograms. So I'm going to write right inside the box 41 kilograms. Now, I know that's a mass. I don't really have room to write M equals, but I know that's a mass. Usually with mass, I'll just put it right in the picture, right in the middle. Now, it says the coefficient of sliding friction between the two surfaces is 0.54. So mu is 0.54. And the question is, what is the force required to move the mass at 5.8 meters per second squared? So that's an acceleration. So we have those are the facts that we know. Now, if there's a coefficient of friction, we know there's friction. So we have to overcome friction in order to make this thing move, and not only move, but accelerate. So I am going to have I'm going to have to do my free body diagram, which is going to have the force in this direction, and it has to be greater than the friction in the other direction. So when I draw those arrows, I'm going to draw them different lengths because I know the one to the right is going to be a bigger number than the one to the left because I know it's going to accelerate to the right. So we call this force right here the applied force. And that's our unknown. So I'll also label it right here on my picture as my unknown. And then we label friction with the italics F. Now, don't confuse friction with the coefficient of friction. I'll have people on the test, and they'll write this, and they'll give it newtons, and they'll say that that's the friction. Okay, there's no units with the coefficient of friction. Every force is in newtons. The coefficient of friction has no units, so don't confuse these two. So those are the forces in the x direction. In the y direction, the object has a mass, therefore it's going to have a weight. And if it has a weight, the surface better provide an upward force to balance that, so that if this thing moves at all, it's going to move in the horizontal direction. So this is my weight, and that's my normal force. So that's your picture. Now, if I'm grading this on a test, that's going to be worth probably 8 points. So it's sort of like you list your facts step. Because I have all my facts on the picture. I know what I know. I know the acceleration. I know the coefficient of friction. I know the mass. So those are the three things I know. I'm looking for that, and these three things I don't know also. So when you're solving these problems, you just solve them in the order that they can be solved. But what helps me solve these are the descriptive equations, because they give me a relationship between all of these variables. So when I sum up my forces in the x direction, you can see on the picture that there's only two forces that are in the x direction, one to the right and one to the left, and sum means adding them together. So I'm going to add a positive number with a negative number. So rather than write plus minus, I'm just going to say Fa minus friction. So those two together are what equal the F in the formula F equals ma. When we talk about Newton's second law, that's the unbalanced force. This right here is the unbalanced force. So this has to equal ma. Now, because these forces are forces in the x direction, then the acceleration will be an acceleration in the x direction. And so this A, it's going to accelerate in the x direction. Now, in the y direction, our forces are going to be balanced because the object is only moving in the x direction. So we have on the picture Fn, which is up, and W, which is down. So we call the up direction positive. Just like on a graph, you'd have, that would be the positive x direction, that would be the positive y. That would be the negative x, that would be the negative y. So we're going to have Fn minus W, and that still does equal Ma. I mean, because that's the unbalanced force in the y direction. It equals Ma, but A in the y direction is 0. Yes?
Are we required to show the F minus W equals 0 if we were to take a test when it doesn't have to do it vertical motion by horizontal?
Yes, because I need to be able to justify that Fn equals W. At some point, you're going to make that statement that Fn equals W. And Fn equals W is not a rule. It's specific to this type of problem. In another problem, Fn will not equal W. It equals W in this problem, but it won't equal W in another one. So formulas like W equals mg and friction equals mu Fn, those are universal facts. I mean, those are universal formulas. So these are always true. These two over here are called descriptive equations. They're not formulas. They're descriptive equations that are describing this picture over here. So you make the picture and then you describe it mathematically over here, so that now I have a relationship between Fa, friction, M, and A, and I have a relationship between Fn and W. So now when you're solving this, you just solve the stuff in the order that things can be solved. Another thing, I told you that the diagram itself with everything on the diagram is worth 8 points, and then I give 2 points for that, 2 points for that. So on a 20-point problem right there, that would be 12 out of the 20 points, and I haven't really solved anything yet. So the first thing I would get would be what? What's the first thing that I could solve based on the facts here in the problem? I can't solve for Fn yet because I don't know what W is. Yep, you can solve for W. So I'm going to get W first, so W equals mg. You should write whatever the formula is, because if you're going to use numbers, I want to know what these numbers are. So M is 41 kilograms, and G is 9.8 meters per second squared. And I remember, I think Grace is the one that asked me about the sign. Why isn't it negative there? If we were doing a straight line motion problem, then we're dealing with the signs for each of the descriptive variables, so I would have it as a negative. But I've already taken care of the direction up here. So if I were to make that minus, I would basically cancel out the direction that I need the weight to be in. It needs to be down. So I've already done that, so I'm only really solving for the magnitude when I'm solving these values here. So 41 times 9.8, what is that? To 3 significant digits. 402. So 402 newtons. Now that I know the weight, what can I solve for? Now I can say the normal force is equal to the weight because of the second descriptive equation above. So I know the normal force also equals 402 newtons. And now that I know that, what can I solve for? What's the next thing I can solve for now that I know the normal force? Friction, because I have a formula over here that says friction equals mu Fn. Mu was given in the problem as a fact, and we just solved for Fn. So now we can get friction, which is a force. So we're going to have friction equals mu Fn. So that's going to be, mu is 0.54. and the normal force is 402 newtons. So what will that answer be? 217? So, okay, so 217, and now there's only one thing left to solve for, and what is that? The applied force, which is what was asked for in the problem. If you look here, I now know that, I know A, I know M, and I know friction. So the only thing I don't know is the applied force. So if I move this to the other side, I have the answer. So I guess I'll do it over here, so I've got more room. Whoops. I'll do it in red, so the applied force is going to equal MA plus friction, because I'm just going to move the friction to the other side. And then just plug in the numbers. So the applied force is MA plus friction. So for the mass, we put in 41 kilograms. For the acceleration, we put 5.8 meters per second squared. And for friction, we put 217 newtons. And solving that, bring it up a little bit more so I can get the answer. What's that work out to be? Hopefully it's the answer I gave you, which was 455. Is that it? Yep. 455 newtons. Any questions with that?